A very good afternoon, everyone, and welcome back to today's afternoon session. This would be a practical session. We're pleased to have Mr. Fazail Amin with us today. He is the lead data scientist at Whilter AI, where he leads the R&D and deployment of AI services across audio video production, agentic AI, and predictive analytics. At Wilter, he has spearheaded the development of several advanced models, including EasySync, Easy Speech, Easy Clone, and EasyVid. His work spans industries like aviation, sales, and finance, integrating LLM based AI agents, 3D point cloud analysis, and optimization solutions. Thank you so much, sir, for joining us today. I would now like to invite you to kindly take over and begin the session.
Hello, good afternoon, everyone. Thanks, Sunana, for the introduction. So I'll be giving a hands-on session on RNN, which will include your basic predictive analysis. And I have created a couple of examples. For that, I will share the data set so that you can also work along. So I would appreciate if you people download the data set and start working so along with me, so that it will be clear to you whatever we are doing here. So let's get started. So I was in the lecture, the previous lecture. Arijit sir was giving that lecture on RNN and LSTMs. So I hope you people have enjoyed that lecture and understand a little bit of maths around that. So it's very much required. Right now you can see most of the work is going on around LLMs and these agentic AI stuff. So you might be skeptic around the learning of RNN and LSTMs, and for that matter deep CNNs. But let me tell you one thing, it's all based on these are right now primitive technologies, but everything is based on this only. Okay, even if you see the transformers, the core idea behind that is RNN, LS and LSTMs only. Okay, if you understand these things properly, then you will be able to understand those LLMs as well. So I just want to know whether you people have any kind of setup with you, like development environment and all. So what kind of setup you people are having? I suppose you guys are using Anaconda, basically Conda environment on either VS Code, or you are using Colab. So Colab has everything. So let me, okay, fine. Someone has replied Google Colab. So I'll introduce both of these things, Colab as well as VS Code, and I'll try to help you with the environment setup. Just a second. All right. So I have received a few responses. So you guys want me to guide you through the setup of your workspace. So I'm waiting for a couple of responses here so that I can go ahead. So let me tell you what are we going to use. I will first show you the Colab setup, Google Colab setup, and will guide you through installation of packages if it is required. In Colab, you have this advantage that you don't have to install the packages. You can directly start using those packages and it will automatically be imported in your workspace. And the people who are working on VS Code, there is a small suggestion for you. If you are on the MacBooks and using Apple Silicon, you will find it difficult to install TensorFlow with pip. So I would suggest that you switch to Anaconda and create a Conda environment and then install the TensorFlow. Otherwise, it won't work for Apple Silicon. All right. So I'll share my screen. So just give me a moment. I have multiple screens open, so I'm finding it difficult to share it. I'll just quit for a moment because there is some permission issue with my system. I will just connect back just in a moment.
Okay, sir. That
Okay.
would be okay.
Actually, audio and video recording is on, so system is not allowing that. So I'll have to reconnect. All right, I'm back. So I'm sharing my screen. Just a moment. I hope my screen is visible. Right. So, so here is a Google collab. So This is a very basic setup of the collab. So from here you can access your directory, your Google Drive, and you can put the data over here. So it will ask for authorization, so provide the access so that it can read and write data from your Google Drive. Otherwise you can keep your data over here in the sample data, but this is temporary storage. It will get deleted once you go out of this collab workspace. And also you can you can have your notebook connected to your GitHub account as well. So here is the link for data. I'll paste this link in the chat window so that you can access this data and start working with that. Send it to everyone. Okay, I have shared the data. So in this drive, you will find two data sets. Basically, I'll go walk you through two examples. One is where you are pulling the data from which data I have already pulled. You are using the share market data for running the prediction on that. So we are using the SBI ticker. So basically, it's SBI data, and then we are pulling it, storing it, then doing the training, and thereafter prediction. So I'll show you the data. So you will find this directory. I have given access to this directory where this is one of the data sets and another is the sales data set. So this is a bigger data set and it has multiple CSV files. So this is a bigger example. I'll explain this later on. So let's get started with first example. Right, let me reset the runtime. Okay, so I hope you guys have started. First of all, we will start importing the basic libraries. One of the most highly used libraries is Pandas. So it's basically for manipulation of tables, or you can say CSV files. So it's a very robust library. It provides a lot of functions to manipulate basically your data in any way you want. So it's a very robust library. And then we have this scikit-learn library for pre-processing. So we are importing this min-max scaler. Basically, this function is used for normalizing the data. And then we have this model selection, which is used for importing train test splitting. Basically, whatever data you are passing to the model, you want to split that data into train and test sets. So this is not necessary when you have already divided your training and test into separate files. So this is not required in that case. And then NumPy for basic array manipulation. Okay. Now here we are importing the data frame, basically CSV file in the pandas data frame. So here you can see this pandas.read CSV. So I have stored my data in CSV file and I'm pulling the data from there and storing it into the data frames. So what I'm trying to do is I'm trying to remove the row which does not contain numeric data in the headers. Basically, in your CSV file, you usually keep the header. So I'm trying to remove that header. All right. So this is very kind of uh, useful if you want to do share market analysis on your own. Basically right now you have a lot of portals available where you can do your analysis on the share market using any ticker which is available. Somebody has message. Okay, data frame is basically a format. It's a pandas format for storing the data. Basically, it reads the data from CSV file and keeps into a temporary storage, temporary array, which is in the format of data frame. So it's internal representation of this loaded CSV file for the pandas. So I hope this is clear. Okay. Okay, I was explaining what you can do with this kind of data. Basically, if you want to invest your money in some portfolio, so what you can do is, you, for example, here I have taken SBI data. You can take any data which is available, and it is freely available. So there is a package called Y Finance, using which you can download the data for any ticker. For example, instead of SBI, you can take HDFC, Reliance, or any other listed company you want, and pull its data for whatever time it's available. For example, some companies data is available for 20 years, some companies data is only available for 5 years because that company is very new. So you can get the data for the company, and as you know, this contains these attributes. For example, the closing rate. So what's the highest rate it has gone, what's the lowest rate that particular share has gone, what's the opening price, and what's the volume. Okay. Since we know these are the columns in this particular CSV, otherwise we could have checked what are the columns available in this. Since we have removed the top attribute, so it would be difficult to get these attributes after this. So you can check the first row and get these attributes, what are the names of the attributes in the CSV file. Okay. Now I'm trying to convert the data into numeric form. Basically, we are trying to, there can be some data which is non-numeric. For example, some missing values might be there, or some data which is not numeric. For example, somebody has written null over there. So that can also be there in the data. So what this line is doing, it's pulling the data, it's converting it into the numeric form, and it's coercing the errors. If there is error, it is trying to resolve that. Wait, I got some message here. Okay, somebody asked, all data type means all type of data needs to be stored in the data frame. Yes, if you want to do some kind of processing on the CSV file via pandas, so it has to be pulled into data frame. And there will be situations where your data set is too big. For example, let us suppose it has 50 million rows. So the amount of data you can store or you can pull in the data frame is decided by the capacity of your system. So if your RAM is high, it will support uh, that much data, then it can fit into a single data frame. Otherwise, what you can do is you can use the chunking approach. You can chunk the data into multiple data frames and then use it. So we are removing the first row because first row has only the this attribute name. It does not have the numeric values. For example, first row will have this close, high, low, open, and volume terms. So we want to remove that, and we have indices which represent these attributes. For example, column 0 will be close, column 1 will be high, column 2 will be low, and so on and so forth. All right, now we have converted the data to numeric, and now what we are going to do is we are going to fill the missing values. Basically, if there are some values which are missing in the rows, then what do we have to do? We have to somehow fill the values. Otherwise, we cannot pass it to the model. All right. So we are filling the values with the mean. So this is called imputation. And there are multiple ways to achieve this. For example, if we have numeric values, for example, for this particular use case where we are analyzing the data for share market, so it's all numeric values, and mean will be applicable to this. Otherwise, for example, if there is some data where it's a gender information, then you cannot take the mean. If even if you have converted into the 0 1 representation, for example, in ordinal values, still you cannot take the mean of that. What you have to do is you have to take the median, or you can choose any other approach to fill the missing values. So it's up to the data scientist what kind of approach he or she is following to do the imputations. All right, so we have just taken this close attribute for demonstration. Okay, just one thing I want to explain here. This minus one comma one. So any attribute or any array, if you want to change the shape of it, and you don't know the shape of, you don't know the dimension of one of the axes, then what you can do is you can put minus one. So this dimension one will have one element, but dimension zero will have elements which will completely fill it. Basically, if you have 20 by 20 by 2 array, and then you want to reshape it to minus 1 comma 1, so what it will do is it will put 1 at the first axis, first dimension, and it will have 40 elements in place of this minus 1. Okay, so this is basically how we reshape. So it's very common approach and it's used everywhere. When you don't know the how many elements will fall in this particular dimension, so you put minus 1 over here. Screen. Yes, it can be done. So why 40? Because we have total 40 elements. So I'm just giving example. It's not related to this particular data. Even if it is 3 dimensional or n dimensional array, numpy array, you can use minus 1 at any of the dimensions for which you don't know the exact value. So it will try to fill that value on its own. All right. Now, data can range from any value to whatever value is available, whatever value is supported by the system. But for the model, what we want to do is we want to have this range between some fixed values. So why do we basically do normalization? It makes your data scale invariant. So that is the main reason. And another reason is it will be much more suitable for the model. That's why we are doing the normalization. So it's doing min-max scalar. So it's function defined inside scikit-learn. So we are using that now. So just note how it is done basically. First, you create an object of this min-max scalar, which has range from 0 to 1. And then using this object, you can apply the transformation on the data. Okay. So this is how it's done. It's similar for all kind of operations we are doing. For example, any kind of transformation you are trying to apply on the data, you have to follow this particular method. All right. I should split this, I think. So I'm defining a function. What I'm trying to do is I'm trying to create the sequence for training data sequence basically. We have not put in next. So let me see. Yeah, here it is from sklearn. Okay. So what I'm doing here is I'm creating a function which will return me the data in the format in which I can put it into the training. Feature range. Okay, this feature range you can choose any number, but normalization should be done between 0 and 1. That's the standard practice. Here you can choose 0 to 100 also. That's also possible. So it will work. So this is basically used for bringing the data between 0 and 1. So that's basic normalization, nothing else. So we will discuss this function when we call this. So it's very basic function. It's creating two arrays from the input data based on the sequence length. So here we are setting the sequence length of 60. So basically, this is time series prediction where you will have a particular length of window which will be used to predict the next day's value. For example, you will analyze the data for 60 days and then you will predict the 61st day's value. What would be the price or what would be the low or high price of that particular share. So this is the sequence length which we are using. It's set to 60 here. Now we are creating the sequence. So this is X and Y. So basically train X and train Y. Now this function is called. So basically you put a window of length 60 on this particular data, this scaled data, and then you are creating the chunks of that. And correspond along with that, you are creating Y values using that sequence length. Okay. Now what we'll do is we'll split the data. Let me break this thing. Let me break this thing. Let's run it. Okay, it ran successfully. Okay, now we are creating the training and testing data. So here we are using this train and test split. So this is again a function which we have imported over here in scikit-learn model selection. And you are telling it to split it into 80-20. So 80% of the data will be in the training and 20% will be in the testing. So you can leave this part empty also, random state. So basically it decides, it's a random number generator, basically nothing else. So from what point it is splitting, otherwise split will be fixed. So if you put some kind of randomization, split will be not fixed, it won't be fixed from a particular point. All right. So I have RNN. Okay, now what I'm trying to do is I'm trying to reshape the data. So basically I want a one-dimensional data. That's why I'm trying to reshape the this particular X train and Y train. Sorry, X train, X test. Okay. So this is the input shape. So this is X and Y, and the output of uh, the corresponding output. Let me run this one. Then it will be clear. All right. So as you can see, input shape is 60 is 60 comma 1. So it's a two-dimensional data, but it has 60 elements just in one array. So why we have done this thing? It's very important to notice this. Even though it looks two-dimensional, and it has to be two-dimensional, because if you are passing multiple batches into the model, it will take this kind of shape. For example, if you have 10 batches, it will become 60 comma 10. So those 10 batches will be stacked. That's why it's this is showing 60 comma 1 shape. So it's a single array with 60 elements, but it's put like 60 comma 1, which makes it two-dimensional. Why? Because we can stack multiple batches in a single array, single two-dimensional array, numpy array. Okay. Okay, there are some functions in the pandas data frame where you can have the information about the data which is there in the data frame. So it will give you information, and there is another function which is called head. It gives you top 5 elements of that particular data frame. So let's run this. Okay. So it gives you information about the data frame, and then it gives you the head of the data frame. Sorry, this one. So sometimes it's very important to note this particular type of data. That's why this particular info function is given. A lot of times you will want to convert this float 62 into float 32 also. Okay, now let's come to the modeling part. So we are importing TensorFlow. So there are two ways you can create this particular model. So if you can use TensorFlow and then Keras, which is inside the TensorFlow, because TensorFlow has taken up the Keras, and now it's part of the TensorFlow itself. Or you can use Keras as a wrapper on the TensorFlow. So that example also I'll show you how it's done. Yes, you're right. Float 64 to 32 is basically, for example, if you have a very big CSV file and all the values are in float 64, it will be very difficult to hold this particular data frame and do the processing on this particular data type in your system. So you can convert it to float 32. You will lose a little bit of precision, but it won't matter much unless you are dealing with very uh, high precision data. For example, microscopic data or some kind of computational biology data. So that will have impact. Otherwise, normal numeric data will work in float 32. All right. Now we have imported TensorFlow. Then we import TensorFlow.keras.models. So there are two types of modeling approaches. One is sequential, and the other one is functional. So what we are doing here is we are importing the sequential class of the models. So what's the basic difference between sequential and functional models? Sequential models just stack the layers one over the other, and the flow is from one layer to another layer. That's it. It cannot have any kind of feedback loop or dropout functions. Dropout functions, not the dropout ones. The functions, the layers from where you can tap the output and pass it to another layer bypassing certain intermediate layers. So that can only happen in the functional class of the models, not in the sequential models. So if you are trying to create something where you want to add the residual layers, in that case, sequential class of models won't work. So for that, you have to use functional models. All right, now we have imported simple RNN. So RNN module is already available in the TensorFlow. So we are importing that particular class of layers, and then we're importing dense layer from there, from the TensorFlow. So here is the definition. So we are creating it as a class. If you want, you can create it without class, all without function also. You can just write write the model without any function, so it will work like that also. But you have to schedule the calls properly. Okay, so what it will take the input shape and the output shape. So it's very important to understand that in any kind of CNN models or RNN, the input shape has to be decided uh, before training, or it has to be fixed after the training, because the model will take that shape only. So you cannot pass, for example, in a 60 by 1 trained model, you cannot pass the 60 by 2 by 3 input shape. So it won't work. So this is very important, that you should know the input shape and what is the output shape. So I'm creating an object of class sequential, and then I'm adding the layers. So it's calling a function add, and it's adding simple RNN layer, which has 50 units, and it returns the sequences. So that has to be true. Okay, and then input shape. So since this is the first layer, so you don't have to define the output shape in the layers, except the last layer. Okay, then you have second layer. You can stack n number of layers like this, and you can make this model as much deep as you want. Okay, then I have added a dense layer. Basically, dense layer is a fully connected layer, where every unit of the previous layer is connected to every layer of the next layer. So this makes your dense layer. So it's very costly. So it is always put at the end. So this becomes your classification layer, this becomes your prediction layer. So this is the final layer, which gives you the last output. So any questions? Yes, we have some functions in both. Yes, you can have same functions in both sequential and functional class of models. The only difference is, in the sequential, you cannot have feedback loops. You cannot have dropout connections. That's it. So if you want to use any combination of these layers, then you should always try with functional model. Okay, somebody is asking what are the units in the model. Okay, let me answer first question. What is the number of units? So it's a very good question. What are the units in a particular model, in a particular layer? So what do we mean by the layer, first of all? Okay. So these are the activations. Okay. These are the activations or the feature maps which you get after passing your input to a particular layer. For example, if you have a layer with uh, 10 units and the next layer is with 20 units. So where are the weights? Weights are in between these two layers. What are the connections in between these two set of units? Okay, so that thing is the weight. So writing 50 here does not mean it has 50 weights. Okay, okay, and also to which layer a particular set of weights belong? That is also a very important question. No, it does not mean we are folding 50 times. No. For example, let me give a very basic example. Let's take a very small size. Let's say a layer n has 2 units and another layer n plus 1 has 4 units. The number of connection between these two layers will be, if you exclude the bias. So every unit in the second layer will be connected to every unit in the first layer. Okay, so for every unit in the second layer, which is basically 4, it has 2 connections, and that means 2 weights. So we have 8 weights in all in the layer n plus 1 if we are excluding the bias. Okay, and if we add the bias, it will have 2 more biases, so it will have 10 weights including the bias. Just let me clear this particular doubt. So number of weights will 8 this 10 weights will belong to layer n plus 1, not to layer n. Okay, so I hope this is clear. So once we see the summary of the models, then it will be much clear. Uh, shape and so input shape and output size I have already explained. Each unit. Okay, yes, you can call it as a neuron, and the connections are synapses. So those are basically the weights. Okay, then the question feedback. That's feedback of RNN. Okay, so this RNN, so this is a good question. So how are we passing the feedback of RNN if it is sequential? See, the model is sequential. The model is made of several units, several submodules. This RNN layer is a submodule which is defined with whatever feedback operation which is available in the RNN. So RNN layer itself can have any kind of structure, but the overall model in which we put this RNN layer will be sequential. Okay, I hope this answers your question. Yes, we are considering last 60 days. Okay, so I hope this model definition is clear. So we have two RNN layers, one dense layer, so which will be basically your output size, and then we compile this particular model. So compiling model means you are collecting the information about the layers and what kind of input is going through these layers, and you are defining the optimizer, which is used for basically running your back propagation and updating the weights. And you are using this loss mean squared error. There can be n number of losses which you can use. So you can find out about optimizers and losses on the official website of TensorFlow, PyTorch, Keras. Let's run this. So while it's running, let me see the messages. Model of RNN includes input X previously. Yes. So the definition of RNN layer includes all the stuff which you have seen in the previous lecture by Arijit sir. So everything like input X and what is the output state, HT minus 1, these hidden states. So everything is defined over there. Okay, we have compiled our model. Just let me add. I have not initialized, that's the problem. So it will work. Get this thing. All right. So I have created this object of our uh, of this RNN class model. So here is this model, and I'm checking the summary of this particular model. So here you can see. So it is saying it has a simple RNN layer which has this particular shape. So here you can see the output shape is 60 by 50. We have not given any output shape over here. So how is it coming 60 by 50? So 50, we have defined the size of units, and then we have 60 here, from here. Okay. So this is length of input. All right. So you have trainable number of parameters 2600 from here. Okay. Since this is a simple RN, they are not using biases. Why they are not using biases? Just a second. Okay, it's there. It's there. It's not in the first layer. All right, then simple RNN layer 2, which has so this none. You can see here none is coming. So what is this? Can anyone has any idea of this thing? Can you drop a message if anyone knows? So this unfolding is coming from that 60, not from this 50 unit. It's not coming from the unit size. It's coming from the time step size. So the time step size is 60. So that unfolding will come from there. So this none is basically coming in place of batch size. If you pass, uh, so this will take its value on the fly when you're running the training. So that's why it's none as of now, but it is there. It's a placeholder. Okay, this output of dense layer is just one dimensional. I mean, it's a two dimensional if you stack multiple batches, but it will give you just one value, which is what is the prediction, what is the predicted value. Okay, so we have built our model. Now we will train this model. So it will initialize the model once again. So this is redundant because we have already run this particular line over here. So if you see, training has started. So for running the training, you have this model.fit function, which starts your training, and it will fit the data. So this is the data you are fitting to your particular model, this one, which is X train and Y train, for 10 number of epochs with batch size 32 and validation split of 0.1. So 90% of data will be used for training, and 10% of the data will be used for validation. Okay, so it's very small model, and we have just used 10 epochs. So the training is complete. And what we're doing is we are storing the uh, callbacks to this particular variable. So when this model.fit is running, there are callback functions which basically saves your training data, training matrix. So that training matrix can be your loss, validation loss, accuracy, and all these things. So it is going here in the history. So why it is important? This is important to analyze your training. So here we are trying to analyze what has happened throughout the training. So from history, I'm taking the loss. So it's kind of dictionary from where you are taking the loss value and putting it the training loss label. So we are using PyPlot to plot this particular training callback. Okay, let me run this first. Okay, so you can see your validation and your training loss are aligned, so it's going in the right direction. So let's try it for some more epochs so that we can see some kind of different situation here. So while this gets trained, let me explain this thing. So from matplot library, I'm importing this package pyplot. So this is basically a function which plots the graphs in Python. So I'm creating a figure object of size 12 by 6. So you can take any size. So there are options where you can have multiple subgraph in a single graph, in a single pyplot figure. So that you can check yourself how to get there. It's very simple. Okay, then I'm taking loss from the history, and then validation loss from the history, and then plotting them. Okay. So any questions up to here? So I hope you guys are also running this code alongside. Okay, somebody is asking if units equals to 50 in the input in size, then what is the input shape? So what you are defining here is you are telling the layer that you should keep number of units over here equals to 50. Okay, and these are linear layer, single one dimensional array, and you have the input of size 60. So each of the value from that 60 sized input will go to every 50 units. Okay, so it becomes 60 cross 50. So number of weights will be 60 cross 50. So each element of that 60 whatever that array is, whatever value is there in that. For example, let us suppose it has some values, integer values. For example, first unit has one value, it will be multiplied with w1, and it will go to first unit of that layer, and then another value will be taken from that 60 array, and it will be multiplied with w2, and it will go to the second element, and so on and so forth. For each and every element of the input array, it will be multiplied with a weight w, and it will go to one of the neurons, and it will be repeated for all the neurons. So I hope this is clear. Here, can we view the backdrop thing, or how the gradients are calculated during training? Unfortunately, you cannot see how these are calculated. So it's internally represented in the in this TensorFlow. But if you see here in the model definition, we have mentioned. So what optimizer should be used? This is the stuff which is doing your back propagation. and this back propagation is done based on this particular loss value. So loss is your mean squared error, whatever error is coming at the end of the model output, and on top of that this optimizer is applied. So this optimizer is doing the back propagation and the weight updates. I hope it's complete. Okay. So what I wanted to see here was uh, the validation loss and the training loss should go in different directions, but it's good that it's going in the right same direction and it's aligning. But when validation loss curve is not aligned with your training loss curve, then you have this idea that okay, your model is not getting trained properly. Okay, so this is the indication when the model is not getting trained. That's why we need plotting and all those stuff. And there is a very good package called tensor board. So whatever logs you are generating on the training, it can be visualized in the tensor board. It's a full-fledged visualization platform for your training data. Okay, in the training, whenever you are doing some kind of very big training, for example, you are training some generative model, and it has multiple modules. uh, for example, you have to monitor the status of generator, you have to monitor the status of a discriminator. So you need a full-fledged dashboard for monitoring the whole stuff. So for that we have a package called TensorBoard. It's part of TensorFlow, but it works on all kind of machine learning training modules or training packages. For example, it works with the PyTorch, as well as it works with the PyTorch Lightning, ORT, and any kind of machine learning framework. You can visualize the training logs. Okay, now the model is trained. So let's evaluate the model. So from sklearn, I'm importing the metrics, and from there we are using mean squared error. So let's evaluate this model. So how you are evaluating? Model.evaluate. There is this function which is defined inside the model, so which you can use to evaluate, where you are using your X test, which you have created from the 20% of the overall data, and the corresponding Y test. Okay, then you have the predictions. Just a second. Okay, then you have the predictions. Here you are evaluating the model. Okay, we are not running any kind of prediction. Then we are doing the predictions on this particular X test, which will give you the output as Y test. So here you can see why we are doing this inverse transform. So any idea about this? So right now the predictions will come in the form of normalized values, because we have applied the min max scalar at the top on the complete data set. Now we have to inverse that effect. So for that we are using the same handle object which we created from the min max scalar, and we are calling the inverse transform function. So earlier we called fit transform, FIT transform. Now we are calling inverse transform. So it is bringing the data back to the original range. Okay. So we are doing this for predictions and the y test, both of them. And then we are calculating the root mean square error of the predicted versus the actual values. Let's run this. Okay. Okay, now we have calculated the predictions. Now we can plot the predictions versus the actual truth. Okay, so you can see it's aligned properly. So a very small model like this is also working for this particular data set because we don't have a big data set. It's very small. Okay, so we have done the visualization also of the stock prediction. So, okay, somebody has asked this question. Building a model right now, models are very big. Okay, huge models, but you have to understand the nuts and bolts of the modeling. So you have to understand how these particular models work. Otherwise those big models won't make any sense. Right now, if you see in the predictive analysis, especially for the share market analysis, transformer based models are being used. So if you try to write the code for transformer, it's very difficult. So nobody is writing the code for transformers. You have the libraries where transformers are defined. For example, diffusers library from the Hugging Face. You just pull that library, import that particular diffusers library. You can use any kind of transformer which is available. You can use any kind of variational auto encoders, decoders, whatever is available in that particular library. So before this, let me tell you. Right now, why it is showing myself? Okay. Here we have defined this particular line. We have just used this simple RNN. We have not defined this particular module. This itself is a class, this RNN. But we have not created this class by coding line by line. We have just used this as an object of some uh, predefined class. Similarly, what right now we are doing is we are using the transformers as the base classes and we are building on top of that. Are you getting the point? So instead of importing the layers and stacking the layers, we are stacking the transformers. But before going to that, you have to understand how these things are working. All right. So I hope whoever is trying this example has done this. Okay. One important thing, somebody was asking in the lecture, how can we see the weights? What are the weights in the model? What are the values of those weights? So here, when you are training the model, you can go into the layers. So for layer in the model dot layers, you are taking the weights in this particular variable weights, layer dot get weights. So from instead of get weights, you can get biases also. So you can write get biases. So it will get the bias from that particular layer. Okay, and then we are trying to print it. So here you can see we are just printing the shape. All right. If you want, you can print the values as well. Okay. So here you see what values are there in the model. Okay. I hope it makes sense. Okay, any questions you want to ask? Now you can ask because we are done with this particular code session. So I'll move on to another code. So I have prepared another example. Okay. Okay. So I don't think anyone has questions. So let me give you some additional stuff in this. Okay. So you are forcing the model to load even if there is some error. Okay. If you don't coerce it, if there is some error, it will stop. So a similar stuff happens when you are loading a pre-trained model. So there is a term called force. Just a second. Okay, when you are loading the model, there is a term which allows you to force load the model even if some of the layers are missing. For example, you have a particular definition of model. Let me explain you with this particular example. Okay, this is the definition of your model which you need to have for loading the weights of this particular model. Okay, so this is the definition of model. Okay, so basically this is the definition. How many layers, what is the shape of the layers, so which corresponds to this definition in writing. And corresponding to this you have weights here. These are the trained weights, okay, which you save. When you're trying to load this model back to this particular definition, if any of the layers has mismatch in the shape, for example, instead of 50 it's 49 over here, so the trained weights will not load in this particular model. So for that, if you allow the force loading, then it will load and it will drop whatever layer is not matching. Okay. So there is no as such constraint which you can put, uh, which is predefined, but you can force it yourself, that what should be the constraint. So for example, while training you can decide what's the minimum value the loss should reach before it stops, or what would be the value where you are stopping the model. So for example, there are training approaches where you put the early stopping. So it's based on that constraint only. Okay, somebody is asking what are the non-trainable parameters. So weights and biases are trainable. Rest all the parameters are non-trainable. Here you can see non-trainable parameters are 0. So what we can do is, if we make a particular layer non-trainable, then it will come over here non-trainable parameters. So that approach is used when you are trying to build a model. Let us suppose uh, you are trying to do some kind of prediction, even the time series prediction, and you have taken a pre-trained model for some pre-processing. Okay, and you don't want to train that particular model because you know it's trained properly, and in that model's embedding space you are trying to train a new model. So the new model will be trainable and the pre-trained model will be frozen. Yes. So like pre-trained model, we freeze some layers. We can freeze some layers, but in this particular case, there is no point of freezing the layers. You can freeze the layers. In fact, you have control to that extent that you can specifically make some of the weights non-trainable. So each of the weight has a parameter called is trainable, is underscore trainable. If you make that parameter false, it won't train. Okay. I'm coming to this question. Somebody has asked, prediction is regression. So we can use logistic or polynomial regression. Yes, you can use this thing. But the point we are making here is it's a time series data also. Okay. So you are trying to find out a trend in the time domain. Whereas if you're trying to do a regression or a regression on this particular data, you are not going to uh, consider its seasonality, the time aspect of the data. So are you getting the difference? So these two are separate things. Bringing the time information in the data versus using the data as it is, but with no time constraint. So it cannot find the seasonality which can be reproduced in the future. Yes, its freezing is basically making is trainable. No, no. Yes, is trainable false. That means it's frozen. It won't train. So I think regression versus this time series prediction is clear. Aditya Avasthi. All right. Okay. So some additional stuff. So doing these things line by line and understanding each of these things is crucial, extremely crucial until you understand these things and you are able to interpret this. So if you are able to interpret this, there is a magic tool available from Gemini. So I hope you guys have been aware and been using this thing, Gemini. So how many of you understand this Gemini DSA agent, data science agent from Gemini, and how to use it? So anyone can comment on this? All right. So let me give you. So here you can see this Gemini button. Just click this thing. Okay. Now it's asking me what can I build for you? So I'll do it. Okay. Hmm. So I will ask it to create it from scratch. I will not paste it here. I will just tell it I want to generate this RNN model from scratch using simple RNN model. All right. Now, somebody was interested in understanding how this sequential stuff is working. Now you can see how the sequential stuff is working and what is the definition of RNN and what are the things which you have seen in the lecture. So it has generated the code for that. Okay. And it's just using NumPy, nothing else, no backend library. Okay. So you can compile this code. You can create this object. Okay. Now I'll ask it to create the model from that. Okay. It has already created the model. Let me accept and run this model. Now, can you say it is exactly the same model? There will be some differences, but the same model, but it's running very, very slow. Okay. because we are not utilizing the efficiency which has been uh, provided by the efficient implementation of these algorithms in TensorFlow. So now you have the same model written from scratch without any library. Okay. Somebody was asking a question. So basically, the dimension of X train and Y train are single dimensional, one dimensional arrays. Okay, so this you have got. Okay, this example is done. All right. So Gemini is available out of the box in your Colab notebook for data science projects. So let me show you what else it can do. Let me create a new notebook. So this is so 745. What this 745 showing? It's the number of batches it has created from the original data. Each of this batch has 60 comma 1 values. So we have 745 batches of 60 values each. So this is what it means. Okay. Release notes. Why I'm getting this thing. Okay. So I'll show you something which is very interesting. Let me connect my Google Drive. Okay, how many people are using Cursor, Windsurf, or any other coding agent? Okay, I don't think anyone is using these things. So it's okay if you are not using. Okay, so why, as per your calculation, it should have 44,700 elements, but our data set has roughly 5,000. Yeah, that's true. Because we have the overlap. So it's not that I'm creating 60 elements and then jumping uh, to 61st element to 120th element. It's not like that. It's a windowing mechanism. So you have a window of size 60 and then you move that window by one and so on and so forth. Okay. So if you are not using any kind of coding agent like Cursor or Windsurf, then Gemini is there and it's almost free. So even if you use it every single day and hit 500 calls, even then you will not exhaust your free quota. So for that you should have a Google account, and you can use this thing. Let me show you how. So this is my data set, and what I will do is I right click on this particular data set and click add to Gemini. Now I can ask Gemini to create the complete execution plan and create the code base for me. So what can I do? So let's create a time series model for data set. Let's use LSTM this time. Using LSTM training the predictions, the training and prediction graphs. That's it. So it's writing all the steps which will be involved, and it's asking me whether I want to accept this or not. Let's hit accept and run. Okay, so it will execute all these steps, which includes your preparing, load and pre-process, create sequences, build and compile LSTM model, train model, make predictions, inverse transform, then visualization, and then finishing. So it is waiting for my response to accept and run. So I will hit accept and run. Okay. So it is running these things and it encounters error. Even if it is encountering any kind of error, it will try to resolve the error on its own. So you see, it has run the code, it has found the error, and it is analyzing the error. Okay, and it has given me the suggestion also, and it will write the code itself. I have to just accept it. Okay, so I'm not doing anything. I'm just accepting whatever it's doing because it encounters error every now and then it tries to resolve that error. Okay, still asking accept and run. See, it is building model on its own. Okay, it's asking me. So while it generates the code and it waits for the input, you have the option to input anything you want. If you want to add some more layers or you want to change the shapes, you want to increase the number of units, you can do it here when it's waiting for your input. So I have not written a single line yet. I'm just doing accept and run, accept and run. That's it. Okay, how many books completed? All right, 50 books done. Okay, it has trained the model. Now it's waiting for my input. Okay. Yes, this is very good question. So, do we need people who are very good at coding? Absolutely yes. Absolutely yes. Because what happens if you get stuck in the code which is being generated by the coding agent? It's absolutely difficult to debug. It's a nightmare. So, let me see if I have some code base as of now. At our workplace, we are heavily using this cursor and windsurf, but those have this problem. They generate code they generate very nice code base. But if you don't know the coding basics and if you're not good with that, it will become very difficult to debug if anything goes wrong. Why? Because you have not written that particular code base, so you don't know the overall structure and overall flow of the code. So it becomes nightmare to debug that kind of code. So for that, it's very good approach. When you are trying to generate the code, you generate small codes, not the complete code base. So you must have heard about this vibe coding. So when you are doing the vibe coding, it should not be like you generate everything in one go. You try to generate small pieces of code base. For example, here I have given it to do everything, but it should not be done like this. I should know that first I have to do the pre-processing and I have to generate the code in that manner. For example, I will ask to do the pre-processing only. And once I go through that pre-processing code, then I will ask it to do the loading and imputation of the data. And once I verify that particular code base, then I'll move to create the sequences, build and compile, and all those things. But I should not write in one go. And this Jupyter notebook, it's easy because everything is in one page. But when you are generating enterprise codes, big commercial codes, then it's very difficult to handle that, because everything will be in the Python scripts, and there will be hundreds of files which are getting generated on its own, which you don't know whether they exist or not, and you haven't seen those files, even one line from that file. So it becomes a nightmare to debug and track anything if it goes wrong. So we have to be very careful when we are using these tools. These tools are very good and they can increase your productivity at least 5 to 10 times, but it comes with its own set of challenges. All right, it has done everything. So I haven't written a single line of code and it has generated everything. Will be applicable for real-time medical images and how to improve the metrics and parameters. We get very low results. Okay, so these are just basic models. Right now, whatever there is in the domain, in the AI domain, are very good models, which are proven models, and they perform very well. But yes, even though they perform very good, they are probabilistic models. So everything will have some error tolerance. So that you have to be ready to accept that, or you have to make provisions for that kind of errors. So model will do the errors, it will make mistakes. And for example, in this particular model, if you want to improve this model, You have the way of adding more layers, changing the optimizers, uh, adding the transformation in the data set, increasing the data set. There are a number of options. Okay, will this code consider for research because we are doing others code, right? See, research, if we are doing research and it needs coding, so the idea is the primary thing, not the code. So idea coding is just to translate your idea into the machine so that it can be trained. For example, if you come up with some very good optimizer, let us say a very robust optimizer for which you have mathematical proof, so the coding is only the implementation of that particular optimizer. So you can get it implemented using any kind of coding agent. So, so the value is of idea. Okay, so this coding is done. Everything is done by Google only. So you should also try this thing. Okay, let's move to uh, other part, the second problem, where we have the sales data. Is it? Let me see. Okay. So now the other code I will show in the VS code. I will also try to help you guys set up the environment for VS code because sometimes it can be a bit tricky. So let me stop sharing from here and switch the screens. Bits of Sublime. Okay. So this is my VS code. So I have created a project here, so which is this prediction. So what is awesome? Yes. In classification, you don't have the use of time domain. So what kind of classification you can do is that will be in terms of time series only. For example, uh, you can have a column of profit and loss. So you can predict that using this time series. Are you getting the point? So if you have the data of this share market where you have another column which is saying that, okay, right now it's in profit or loss, then you will have the option of predicting whether it's giving you profit or loss. So that, yes, that's possible. No, it cannot be used on that. If you are trying to use on the video, so to some extent you can make use of this, but it won't work. So you will be able to uh, capture the time information, but it's not that usable for videos and images stuff. There are CNNs which perform really good. Okay. Okay, this is another example which I have created. So if you have any other folder which is having the data, you can just import the data over here. For example, if you right click on this pane, you will get this add folder to workspace. So you can choose any other folder available in your system to add it here. Okay, I have added this data. So it has multiple CSV files, but main file is this one, train CSV, and it contains the data of a particular store, and it has entries which show the family of the object. I mean, whatever is being sold, what family that object belongs, then whether there is some promotion going on or not, and what are the sales target, the total sales. Okay, so we have added some details here. Okay, so I was to explain you the setup. So Gemini. Okay, so you can add Gemini in your VS Code as well, but it will not work as smoothly as it works in Colab. So you have to basically ask the question based on the files over here, and you have to copy the code and paste it on your notebook. So that is the only shortcoming of using Gemini in VS Code, but it works fine. It's using exactly the same model which is there in the Colab and gives you the exact same results in this also. So in the extensions, so you will need a few extensions like Jupyter extension, and then you will need Gemini Code Assist, and apart from that you will need Python also. So I have already added these things. Okay, so extensions is done, and then there is this command, Control P. Before you start anything in VS Code, you have to select the Python interpreter. So if you just a second, Control P. Can I move this thing from here? Okay. So how do you get in the command palette? So Control P. So it should open, but it's not opening. There is another way. You hit the Control P, then Shift and this greater symbol. Then you can see the command palette options. So you check the Python interpreter. So from here you can select the Python interpreter. For example, uh, I have selected this thing, test env, so which is here. Okay. So a very important thing, when you are running Jupyter Notebook in VS Code, there will be issues with your environment. First, you have selected the environment from here, and after that, what you have to do? Uh, okay, it's already selected. You have to install IPy kernel. I have already installed it. Let me show you. IPy kernel. So this is required to run Jupyter notebooks. If it is not there, this Jupyter notebook won't run in your VS Code. So make sure you install IPy kernel in the current environment. For example, once you have selected the Jupyter this Python environment, then you have to install IPy kernel, or whatever environment you are creating, whether it's pip, using pip, Python VNV, or using Conda. Make sure you are installing IPy kernel. So that will help you run the Jupyter notebooks. Okay. Now I'm not using the TensorFlow directly. I'm using the Keras wrapper on the TensorFlow. So I have installed TensorFlow separately, and then I have installed Keras. So here you can see how I'm importing this. It's different from what we were doing in that particular example. So here from keras.models, I'm importing sequential. Then again from pre-processing, I'm importing time series sequence generator. So the way we were creating the windows, those 60 samples in one window. So it will do the similar stuff. And then from layers, I'm taking LSTM layer, dense, dropout, repeat vector, time distributed. And again from sklearn, I'm importing min-max scalar. It's for normalization. Then we have ordinal encoder. Why we need ordinal encoder? Because there will be values in the table which are not numerical values, which are basically categorical values. So how do you encode categorical values into numerics? So this ordinal encoder helps in that. And then I'm importing metrics same as previous, and model selection for test train test split. Then I'm taking the callbacks. So now you can see early stopping and model checkpoints. So pyplot similar as before. One thing extra coming dates. Okay. All right, let's run this. Just a moment. This NumPy seed. Why do we need seed? Basically, anything which is generated randomly in the system will be different every time you generate it. So to fix that, you have to put a seed so that the results are reproducible. All right, that's why we need to seed the random number generator. But what doesn't that include for category lines on its own? Yes, we have to call this. I'll show you how it is done, how categorical encoding is done. Yes, I'll share the code with you. I'll share the link of that uh, Jupyter notebook on the collab, as well as this particular code base. I'll share with you. And also apart from that, I'll share you another link, which is our company's official GitHub repo, where we are maintaining a lot of publicly available codes just for training and teaching. Yes, this is a good question. So there is a proper term used for that particular uh, action, where you have to walk through the data set. Somebody has mentioned that we have to see a few samples from the CSV file. Yes, it has to be done. So the data has to be analyzed before doing anything. So there is no difference basically. There's no difference. So libraries are exactly the same. It's only that Keras can be used as a separate package also, and TensorFlow also has added this Keras in its official repo. So TensorFlow officially contains the Keras, and Keras can be used as a wrapper on TensorFlow as well. And the codes are exactly the same. There is no difference in the codes. Somebody has asked, can I create a model to buy and sell stocks in a fraction of seconds? If yes, what will be the best model? So there are lots of debate around that. There are some ensemble models which are used for stocks prediction, and there are, as of now, transformer based models which are used. So coding base, how can you build coding basics? So you have to write the codes line by line, then only it will be clear to you. Generating codes is good, but unless you understand the coding basics, it won't help you. All right, let's run this code. Did I run this? Okay, let's read the data. So it's here, this data. So VS Code has a lot of advantages if you are into hard code coding. So it has a lot of good features. For example, if you hover on any of the functions, it will give you the signature of function. Okay, so you can see the examples also. Everything is there. Okay, this data is loaded. Now this term exploratory data analysis. So I will just quickly go through this. What's there in the exploratory data analysis? So you try to find out what's there in the data, what kind of stuff is there, uh, what kind of distribution the data is following, is there any missing values, all the attributes of the data we are trying to analyze. Okay. Hmm. Okay, so we have these attributes: date, store number, which family the product belongs, what are the sales, is there any promotion ongoing. Okay, and the types of all these objects. Okay. Okay, now you can use this plotly library, which is very good library for plotting the data. Let's see. So here it will plot. So I will not go through this code. You just run this and see. So this is giving you the sale highlights of the data. I mean, of the items, which product is selling more. Okay, the sale variation by month and year, how it performs with these particular uh, parameters with respect to months and year. Okay. Okay, so we have multiple tables over here. So we are trying to analyze what is the relationship between these between sales and the transaction amount with the oil price. So this is for Ecuador, I think, and it's dependent on the oil exports and imports. So it will have a huge impact on the sales. Okay. This is fluctuation of oil prices. Okay, so there is some comparison between sales and the oil prices here. If you see this graph, this particular graph is very interesting. So it follows weekly sales, and the sales is particularly following the oil prices. If you see this particular data of what is happening over here is uh, if oil prices is decreasing, the sales is increasing. So that's the correlation between them. Again, then weekly transaction with respect to the oil price. So it's almost similar. I run this. Okay, so here is the correlation. So oil price has the highest correlation with transactions. Just a second. 0.5. Okay. So it has a good correlation with the sales, total sales, and it has less correlation with transaction. So if you see in the table, so this shows the trend versus this correlation. So it is being captured properly. So EDA basically gives you the insights into the data, what is basically happening, how the price of one thing is affecting the price of another. It will give you way to create engineered features. For example, you can combine multiple features to create a new feature. All right, now we are moving to training part. So it's just basic EDA, which is being called from the previous function. So this is the range of dates. So we get the categorical columns from here. So family is the categorical column over here. So if you see, this is the family. Now we have to change the categorical values to numeric values. So which we will do. These are all the other numeric columns. Store number, sales and promotion. All the columns will be this. Now taking care of categorical features, we will create this ordinal encoder of this class. And again, you see, we are using the same function signature, fit transform, the same which we use in the min max scaler. So we apply this thing, and now you can see it has been converted into the numerics. Okay, now min max scaler will be applied again for normalization. Okay, now we will group the data. So for the same date, there will be multiple transaction entries. So we will combine that to make single entry. And for the sales, we are taking the mean. And for promotion also, we are taking the mean. Okay. Now we have the training data ready. We'll split it into train and test with the same 80-20 ratio. Check the training data. Check the truth values. Okay. Now we have to transform it into the time series data. The way we have created the batch of 60 values in the previous example. So here, this function is called time series generator. Here you are saying how much is the length of history. In the earlier example, we take 60. So here we are taking 30. So here is the value. Key error stat. Let me see. Did I forget to run any of the cells? Can I change it from something else? But it should work for this thing. All right, I have changed the window size. Why it's not working? Okay, so this is the length of generator. So this much samples will be, this much number of steps will be there. So these are the number of batches basically. All right, now I will create the model. again with the same sequential class, creating simple RNN. Oh, I replaced the LSTM with the RNN. Okay, sorry. There is another model. Yes. So we'll run this one. Okay, let's compile this model. So we have 51,651 trainable parameters. And this is the compilation. What's gone wrong? Tensor unsupported. Okay, some step I have missed, I think. Anyways, it will work exactly similar to the previous model. The only difference is the data set. It's a bigger data set. Basically, I wanted to show you the loading problem. Anyways, I'll share this code so you can try it on your end. Okay. So make sure at least you have 8 GB of RAM on your local machine. Otherwise, this data frame will not load. So you have to chunk it. That can be one of the problems. So anyways, I'll be sharing this example and the previous one so that you can run it on your machines. I think we are running out of time. So I'll take some questions. Where is that screen? Any network? Let me see the questions. So how to use tensor? Somebody is asking how to use TensorBoard with PyTorch. Just have to import the TensorBoard in your code, and there is an events file which is generated. So whatever metric you are using in your PyTorch code, you just save that metric in the events log. You will search the code on ChatGPT or any of the resources. You will get the exact code. So just a couple of lines. And when you have collected the logs, or if you want to run the live logging, what you can do is let your training run, and then you launch the tensor board. So it's basic simple command. You have to launch it from the terminal, tensor board, and then log directory and name of the directory where the events file is getting saved. Okay, so it will start a browser based interface for this log information, which you can run on any port. So you can define the port number. Otherwise, it runs on 8000, I think. 8080 it will run by default. So you just open that particular port on your local host, and it will show you the current logs, live logs. It can show you live logs of the training. So it is directly reading the events file in which your PyTorch trainer is writing the logs. So it will show you the live logs. You can monitor it. In fact, you can redirect it on your mobile phone also. So in my team, every single person who is doing the training has mapped the TensorBoard log on its Android phone. So it won't work on Apple, but it works on Android. So they keep on monitoring the training logs. Okay, another question: any network or architecture like RNN or CNN which works on the concept of time correlation will perform good on input data which has temporal. See, transformers are very good with the temporal information. So right now, the state of the art models are transformer based models. Transformers have capability to uh, remember very long context. So it's all about context. So they can keep a lot of information. So yes, transformer based models are very helpful and they are very accurate. Sure, I'll share my email ID. So if you have any questions, you can drop me a mail or connect with me on the LinkedIn. This is my Gmail ID. All right. If you people don't have any other questions, we can wrap this up.
I think there are no more. If there are no more questions, we can wrap this up. Thank you so much, sir, for clear explanations and practical insights. I hope everybody enjoyed the session because I know I did. Uh, Apart from this, I would request you to kindly share all the notebooks,
Yeah, sure,
quote
sure,
notebooks with the participants for their reference.
sure.
Thank you so much, sir, once again for this very detailed, practical hands-on session. Thank you
Okay.
so
Thanks
much.
a lot for having me on board. It was a very nice interaction. Thank you, everyone.
Okay. The code notebooks would be updated on Canvas portal. You can find it on week 3, week 2, day 3. Thank you so much, everyone. Can leave now.